Hello everyone and welcome. Today I will show you how you can use our uh, MBUS to LoRaWAN IoT converter to perform secondary addressing and to read out multiple devices, even if they are of the same type, how you can read them out and how you can send the data to LoRaWAN. So first of all, um, this tutorial or integration manual is applicable to LMD and LMEAC. It means you can use it with both battery powered and AC powered version of our devices. Um, to be honest, I think we can skip the benefits of remote readout of MBUS because it is quite evident, as well as the MBUS presentation. You can check it in the in the text version of the integration manual, and most likely you know quite well about MBUS if you look for a remote MBUS readout. So I will go directly to the functions which are offered by the Lua script running on our device. As LoRaWAN has some size limitation of the size of the payload you can send in one message, our device implements adaptable payload fragmentation LAN, meaning depending on the spreading factor with which your device is connected to the network, it will change the size which it sends at once, and it will fragment the message into multiple frames. The readout period of connected MBUS devices is by default 1 hour. MBUS delay before reading the devices is 5 seconds. You can configure other MBUS parameters such as baud rate if you don't want to run at 2400, which is default. You can configure the LoRaWAN port, of course, and an interesting part is that you can configure a VIF-DIF filter. The filter can be different for different devices, and this is quite useful, especially for LoRaWAN, because we also have a narrowband IoT version where it is also useful, but here I would say it is even more useful because, as I already mentioned, the size of the payload is limited with LoRaWAN. So with the VIF-DIF filter, you can cut out only the parts of the message which are important for you. For example, when you read out an electricity meter and you are interested only in the consumed energy into kilowatt hour, you will set a filter only to the kilowatt hour, and you are not interested, for example, in the voltage value in the current voltage reading. So you can remove all these parts, and you can reduce the size of the frame from, let's say, 200 bytes to maybe something like 40 bytes, which will fit even in a frame in case of spreading factor 12. We are getting to the out-of-box behavior of our device, meaning what it will do when you connect the battery. So you should see a printout which resembles a lot what you can see here. It will print out a version of the script. It will print out what's the name of the variant of the device, and on the first run, and this behavior is already defined by the script, which is editable. So in case you need to tweak it or modify it in any way and adapt it your needs, you can do it. But in this very script, what will happen is that it will scan the bus, it will perform the secondary addressing scan, and any device which will be found will be applied as a filter, meaning that this will be the new list of secondary MBUS addresses which will be read out every hour, every time our device wakes up from deep sleep. Here you can already see how it looks like. So after the scan, the device wants to send this message. This means that it is the first message out of one message in total. F5 is the command byte saying this is the scan report, emboss line scan report, and then here I think are the IDs. Here it means that it found one device, and those parts will be the manufacturer ID and the ID of the device and device type. Not quite sure which byte is which, but we will get to that later. As I mentioned, hardware used in this example, I'm using LMD because I kind of prefer using battery powered devices during tutorials, but there is also AC version. We did some measurements, and this version of the hardware allows up to 5 unit loads, but of course, as you can imagine, if you increase the load on the bus, the consumption will increase, and therefore the overall lifetime of our application will go down and be lower. But we did quite optimistic scenario measurement in case you have only one M-bus device connected to your bus, and you have just a single battery. From this point of view, it is pessimistic because you can also have dual D-cell batteries, which will allow you to have up to 38 amp hours, which doubling those numbers. But with a single battery and a single device on the bus, you can expect roughly those numbers. If you would require more accurate numbers, do not hesitate to contact us. We have different power profiling tools such as OTII Koitec ARC device, which allows us to measure the power profile of your script and exactly measure the expected lifetime. And we also prepare a new hardware version which should allow up to 16 unit loads using diesel batteries, but this is not the topic of this video. As I mentioned, this application has certain limitations. For example, there is the duty cycle. So in case you would set this reading interval to very often, like 1 minute, for example, it can happen if there is a lot of devices, and if you are connected with the slowest data rate, with data rate 0, or also called spreading factor 12, you can hit the duty cycle limits, in which case the device will start dropping the messages so that it doesn't exceed what's allowed by the regulations. And of course, we have the fragmentation to address the limitation of the payload size. We are getting to the description of different configuration messages and the message bytes, which explain what is the meaning of the internal payload. So as I have already shown, first 2 bytes are there because of the fragmentation, and the third byte is the message type, basically showing what is the purpose of the message, of the uplink message. So in case you see F4, it means this message contains the payload, the M-bus payload from no, sorry, this is the gather report. So this one is sent at the end, and this tells you how many IDs in total was read out in this readout cycle. So if you, for example, set the wake up period to 1 hour, every hour the device executes 1 readout cycle, and at the end of this cycle the F4 message is sent. You can see a relative counter, so you can see that this is like I don't know, 200th iteration, and it wraps at 255, and you can see how many IDs were successfully read out. Here is M-bus scan done. What's the difference between gather and between scan? Gather, in the terminology we use in this script, is like the report at the end of a normal cycle when the device is set up, and it repetitively every hour reads out the data on the bus. M-bus scan, on the other hand, its aim is not to read the data from the bus, but to scan the bus and to see what are all the devices on the bus, and then it sends one message containing only the manufacturer ID, version, medium, and ID information of the device appended like this. And you can see that there is, for example, 4 different devices on your bus, and then you can remotely, for example, say, okay, ignore this one and do not ignore that one, and read it out and apply such and such with the filtering for that device, and different with the filtering for other device. Here, this message, this is a reply when you set the list of emboss IDs to read out. This emboss IDs checksum is a message which will report you back a XOR checksum of the IDs which were set, so you are sure that the settings was done correctly, and you can check it with a simple XOR calculation that it is really the case. And there is something called status report, which will report you a version of the script, which you can manually modify when you modify the script. And then there is a configuration acknowledge, which will send you basically back the configuration of the device, which contains the backup period, it contains the emboss baud rate, how much it should retry every readout. When a device doesn't respond, it can retry as many times as you said here. Default is 3. What is the emboss timeout? When it sends a request, it waits for the answer up to 3 seconds. And then there is the scan mode, which is what it should do when it resets, whether it should apply newly found devices and add them in the filter, or whether it should just report to the server, okay, I just reset, or I will just turn on, and battery was plugged in, and this is what I see on the bus, but do not apply it as ID, do not change your configuration, let the backend set the configuration. Yeah, so there are different modes, and there is also initial delay report, which will report you what is the initial delay when emboss is powered on, how much seconds or milliseconds to wait before executing commands. And there is also a description of downlink commands, which pair with the uplink commands 1-to-1. So again, here is the settings. Here is settings of the emboss filter, which means like the list of IDs to read out, which can be set, of course, independently on what the device finds on the bus, but it is reasonable to set it to to pick devices from the list which was reported by the device that it was found on the bus. But it is not obliged. It's up to you to do any logic. Or if you leave the default settings, this filter or list to read, maybe I'd call it, is set automatically to what the device finds on the bus. Here is again the settings, which I already shown you, and yeah, and here is the scan request when you want to force the device to do the scan. And yeah, I think you can go through it one by one in case you are interested. So now I will just check the behavior on startup. So I have opened here our GUI. I click on connect, and as you can see on the video, I can click on config, and here I have the setup prepared. So I just connect the battery like this. You should see the blinking, and if I leave the device like this, it is now in a LoRa bootloader, which means that it is sending messages using raw LoRa, and we have a proprietary protocol to do a firmware update over LoRa, and we can even do multiple devices update at once. It is not using standard LoRaWAN. It is using the 869.850 frequency, where the duty cycle is not limited, even not in Europe, but you need to limit your power to 5 dBm, so we leverage that. It is used by some customers, and we did this because the full firmware is quite big, so this is an efficient way how to transfer the full firmware. But it's also possible to update just the Lua script, which can be done using the application firmware. You can see here the boot up, and the boot up stopped because it got connected to our GUI. I will now read out the Lua script, double checking that we have really our script which we want. And here you can see the version of the script, and here is settings of some state variables, the port, if we should use the acknowledge messages or not, and the timeout for reception, etc. And if we scroll down, here is where the script begins in the on startup function, which we tend to go to put down. So it will print out the version here. It will do some settings of some safety watchdogs we have, safety watchdog feature in our scripting interface, and then it will do the scan, as you can see here, and yeah, it will report the results, etc. So we can see it is our script. We can do any tweaking, we can write it if we want, but that's not the purpose of this video. I just wanted to quickly show you how we can verify that the script is there. And I'm sure there will be a link to this script somewhere in the integration manual as well, so you can find it also there. Okay, now I will maybe the fastest way is I'll just reload connect. If I don't click on the config, the GUI will stay in a mode where it is basically just a serial visualization. So it is just showing what is happening on the serial line, but it is not actively putting the device in the config mode. So now you can see the printout. It prints the version of the script and the variant of the firmware. Here it's a secondary addressing because it's a firmware variant which comes with the secondary addressing scripts as a default. And you can already see that it found this ID. And if I move this closer to the camera, you should see the number there. Maybe it's flipped, yeah. Okay, here you should see it, 2300164 MBUS, yeah. So it's matching, and you can see the device is now joining LoRaWAN. It is sending the full frame here, and that's it. This is the gathering cycle report, and it should go into sleep mode, and now it is in the sleep mode, and that's it. Okay, so that's not where we end. Now I will show you we have the this is our gateway, and this is the Things stack, the Things network server, which we are hosting here for testing. And you can see here there is a join request. Which one it is? Maybe this one. It joined, and there is a data message here on port 100. Here we can see the same data on the gateway, and yeah. Okay, so this is basically the out-of-box behavior. And we can also see here in the serial printout, here is the MBUS frame, which you can distinguish. It started with 68 and it ends with 16. Yeah, so it is matching what I mentioned. This is the fragmentation, meaning that we fit it into one message, and this 0 means that this is the 0th or the first ID which is being read out. Yeah? If there is multiple of them, there would be like 1, 2, 3, 4, incrementing for every device from the list of configured devices to read out. Okay, what we can try now, for example, we can see that the size of this payload goes from 00 to 50 in hex, which is something like almost 80, 90, 80 bytes, which would not fit into one message in case of frame factor 12. However, you can see that here we are connected in data rate 4, so the fragmentation size was set to 208 bytes, so it fits in one message. But in case we would expect the device to be in a place where it would not have such a good signal, it would be good to set a with filter. So let's check this. Yeah, here this is the example with iTrans Hybel, which I am showing you. This is the scan down report. This is the actual payload of the frame. However, in this example there was already a filter with the filter applied, which the thing you saw in my case was without a filter, so it contained the full frame. Here is the frame which was read out. Here's parsed the frame, the same frame parsed, and here is the configuration of a configuration which will set a filter so that we don't read all of this, but we read only this part. So let's try it out. We are here. You need to go into the messaging. Here we switch to downlink, set the port 2, and this is the configuration. So now I can see the last activity was 5 minutes ago. So now I'll explain. The configuration cannot be changed on every uplink message, but when the device is sending the data report for every device, you can have, for example, 4 devices on the bus. It is not accepting a new configuration, but at the final report, which reports how many devices in total was read out, at this point you can change the configuration. So what I will do now, I will wait for this activity to change from 5 minutes or whatever to right now, and then I will schedule a downlink. In the real world, you would have an application listening for data from the device, and when this application, for example, has a request for changing the configuration, and when this application receives the gather report, the final gather report, it would react immediately to the message with the change of the configuration. And as you might know, there is a delay between uplink and downlink in LoRaWAN class A, so the application has approximately 2 seconds to send the request, and this should be plenty of time for changing the configuration. Okay, so now I will click the button so that it executes the cycle, and when I see it goes okay, let's wait. Okay, now I scheduled. I will switch quickly to serial line. Here you can see that it sent the final report. Here it received the configuration. The configuration is here, and it enters the sleep mode. Now, if I click the button, we should see a new readout, and this time the payload should be shorter. Okay, and you can see that the payload is shorter like this. So you can see that the filtering actually works, and the filtering actually works. Okay, so thank you for watching. Uh, you could see in this video how we change the WebD filter. Uh, you could see basic walkthrough of the documentation of the script, and of course there will be a link to this script in this document. So and also link to this document from the video on YouTube. So everything should be linked together. And if you don't find any information, don't hesitate to contact us at support@acreos.com or at novag@acreos.com. Thank you for watching and goodbye.